Hi guys, so in this lecture we'll be talking about nitration and sulfonation of benzene. Okay, so let me start off with that. Nitration. So by nitration, as the name suggests, the benzene will be substituted with NO2 group. So the reaction takes place as follows. We have a benzene ring. We uh, add a reagent HNO3 in presence of H2SO4, and then benzene ring gets substituted with NO2 and forms nitrobenzene. Okay. So now we'll be looking at how as to how this reaction proceeds and what is the mechanism involved in getting the end product, which is nitrobenzene. So first we look at H2SO4. We'll derive at how do we actually get arrived at what structure H2SO4 is having in our inorganic lectures, but for now you can safely assume that this is the structure of H2SO4, and when it reacts with HNO3, the OH and H from OH from HNO3 and H from sulfuric acid gets attracted to each other and forms water molecule. So this is actually not a forward direction, it is in equilibrium. So we'll understand what is an equilibrium in our physical chemistry lectures, but for now you can safely assume that this is the sign in which we want to show the equilibrium. Okay, this is H2O plus NO2 plus OH removes from HNO3 as OH minus ion, so making NO2, making positive charge on nitrogen atom. Similarly, HSO4 minus will be formed. Okay. Now, what this NO2 plus, what the benzene does for this electrophile is, again you have a benzene, and this actually reacts on NO2 by giving its pi electrons to NO2 and thereby making itself a positively charged. And we have H and NO2 here with two double bonds, and then HSO4 actually removes this hydrogen from the structure, the intermediate carbocation, and again becomes H2SO4, thereby sorry, I drew it wrong. This attacks on this hydrogen to make a negative charge here, and this hydrogen leaves the structure as a H plus. So there is there comes a negative charge here and a positive charge here on this carbon, hence they both form a pi bond with each other. Let me redraw it. Forms a pi bond with each other, and NO2 groups get substituted on benzene, forming nitrobenzene. Okay, so this was the reaction mechanism as to how the formation of nitrobenzene happens and the nitration of benzene occurs. Now let us look at how the sulfonation of benzene happens. Now look, sulfonation. So I hope that you understand that by sulfonation I mean attachment of sulfonic group to the benzene. So let us see how this reaction goes forward. We have a benzene ring, and this benzene ring, when placed in a concentrated H2SO4, and the end result is this group attaches itself to the benzene. So I'd like you guys to think about the reaction mechanism of this reaction, and I hope you will be easily able to get it. So let me now move on to the next topic, which is called or the next set of practice examples, which are comparing the rate of electrophilic substitutions. So just a second. Comparing rate of electrophilic substitutions. So here I'll be giving some of the compounds in which you have to determine when the compound is reacted or the substrate is reacted with the same reagent, then what would be the rate of electrophilic substitution for the given compound. We have OH here, CS3, benzene and nitrobenzene. So what would be the rate of substitution reaction? As you can see that this group OHO actually donates its lone pair to form resonating structures with the benzene ring, hence it is a plus M group. This will actually increase the donation power of pi electrons into the reagent or to the electrophile. This is plus I, this is neutral, this is minus M. So rate would be of the this order. So more the electron density on the ring, more easily is the electrophilic substitution of that ring. So let me write it down. More the electron density on ring, more easily is the electrophilic substitution. Okay, so now let's see one more example for the same. We have something like simple benzene, aniline, chlorobenzene, nitrobenzene and orthopara dinitrobenzene or orthopara nitrobenzene. Okay, so what would be the rate? You know that Cl will NH2 will have its plus M effect. Let me write it with a different color. NH2 will have its plus M effect. It is a neutral. This will have its minus M effect, and these two nitrobenzene will have minus M. And this we can ignore, or we can say that it's having minus I on benzene. Okay, so what would be the rate, overall rate? So the total rate would be B, then A, then C, then D, then E. Okay, so next let's get into another topic which is known as ozonolysis. So what is ozonolysis? Ozonolysis is simply ozone plus lysis, and lysis means cleavage or breaking up of bond from the substrate. Let us understand it by taking some examples. So suppose we have structure like this, and this is undergoing ozonolysis. Don't worry too much about the zinc and zinc here, because zinc is just used for the presence, and actually ozonolysis happens in the presence of zinc metal, so it is just used for that purpose, nothing more. So main reaction or the main operation on the substrate will be done by the reagent called ozone or O3. Okay, so what it will do is it will actually break this bond and replace the bond, the double bond on both the sides with oxygen atom. So what would we be getting as a result? We would be getting something like this. Okay, so let's look at another example for ozonolysis of this compound. We have O3. So O3 will attack on the alkene and will replace the double bond with next carbon, the neighboring carbon with itself. Okay, let us look at this example. So what will happen again? This would be the product. Some more example. Let's suppose we have 2 butene. It is passed in this. So what would the product? 2 but ethanol, because butane would be broken up into two carbons, two pair of two carbons, so it would be ethanol. Again this carbon breaking would be there, so we will get something like aldehyde and a formaldehyde, ethanaldehyde and formaldehyde. Okay, we have something like this. What would happen here? Breaking up of bond happens, and we would have something like this structure. Okay, what happens here when we have this and O3 zinc acts here? This bond breaks, so we would have something like plus twice this I can write. Okay, because the last structure will be the same as first structure. What about this? So the cleavage would be at this double bond, making the product something like this plus this. Okay, what about this structure where we have so it would be something like and twice, one of the upper ring, one of the lower ring. Okay, so okay, let's have one more example. We have a benzene ring and it is undergoing ozonolysis. So what would be the product? This thrice. Okay, so this brings us to the end of this lecture. In the next lecture we will be seeing more of the examples on ozonolysis, selective ozonolysis, Wurtz reaction will be continuing on, or we'll be seeing next the Wurtz reaction. So till then, good luck and goodbye.